Why is it that when you're on a carousel, it feels like an invisible force is pushing you outward, away from the center? Or when observing the winds during a typhoon, why do they appear to curve in odd patterns on weather maps? In energy filament theory, these so-called forces aren't newly created forces by the universe. Instead, they arise because you're standing on a map that is rotating by itself, causing you to misinterpret what should be the straight, most natural paths of motion as a curved path with forces pulling you outward or deflecting you. Let's break this down with an analogy. Imagine a large piece of transparent plastic with a grid drawn on it. Beneath this plastic is a playground, and the people on the playground are walking in straight lines, as they naturally would for the least resistance, for the most efficient movement. Now, picture you are holding this plastic sheet and slowly rotating it. As you watch these people walk, from the perspective of the playground, they are still walking straight, merely changing their position. However, from the perspective of the rotating plastic, their path will appear curved, moving to the side. The faster they move, the more it seems like there's a force pulling them out of the straight line, making them deviate. This is the same phenomenon you experience on a carousel. Your body wants to follow a straight line in the energy sea, but the carousel is spinning in a circle, and everything around you, floors, rails, and horses, is moving in a circular motion. If you mistakenly think of not moving relative to the carousel as a stable reference, you'll see that your movement splits between being drawn toward the center of the carousel and being pushed outward. This discrepancy between those two directions creates the sensation you experience as the centrifugal force. Similarly, the Coriolis force works in much the same way, but this time the rotating map is the Earth. Large air masses, for instance, move across the Earth's surface and tend to flow in a relatively straight line along a north-south path, which aligns with the global curvature of space-time. But Earth's rotation affects the trajectories of these air masses, causing them to deviate. As the Earth spins beneath them, the ground moves, and this causes the wind patterns to curve. So, when you look at a weather map, you're seeing this shift. The straight line of the wind is broken up into two components, one that moves in the intended north-south direction, and one that is subtly deflected by Earth's rotation. This lateral deviation is the Coriolis deflection. So, when you feel like something is pushing you outward on a carousel or pulling the wind in a curved direction in a typhoon, what you're really sensing is the result of standing on a rotating reference frame. It's not some mysterious, external force at play. Instead, it's simply the path being distorted by the frame of reference that's spinning. The most efficient and direct path in the energy sea, when viewed from a rotating map, will appear curved. What we interpret as forces are actually just the natural effects of these distortions in our view. In both cases, these so-called forces are not actually forces exerted by an external agent. Instead, they are byproducts of how we perceive motion from a rotating or changing reference frame. The straight and most efficient path becomes bent due to the distortion of this frame, and the forces we feel are merely the result of this misinterpretation. Tap follow, share it on New Physics, Clear Universe.